So we saw in the previous lesson how to convert between exponential and logarithmic forms. We want to look at the properties of logarithms, or sometimes called the laws of logarithms. With a logarithm, we can go back and forth between the exponential forms like we've seen. The bases always stay the same, and our inputs and outputs swapped. So if we are looking at these, if we have a log base b of 1, log, no matter the base, log of 1 will always equal 0, because what it's saying, if I converted to exponential form, that would be b to some power, which is 0, equals the 1. And it doesn't matter what the base is, so if I had the natural log of 1, it's still going to be 0, because e to the 0 is 1. If I have log base b of b, where the base is the same as what we're taking the log of, it's going to always equal 1, and that's because b to the first power, if I converted base exponent, equals b, what we had the log of. Now these, log base b of b to the x, is going to equal x, and that's because b to the x does equal b to the x. Similarly, these things are inverses of each other, so b to the log base b of x will just be x. So this is because really of inverse operations. We're going to see that a little bit more when we start to actually solve equations with properties of logs. But for now, we just know that if we had log base b of b to the x power, whatever that exponent is, it's going to be what the log is equal to. The last thing here says that log base b of x equals log base b of y. So if that is true, and the bases are the same, then x would have to equal y. The insides would have to be the same. That's because of the one-to-one property that we had. For it to be inverses, they had to be one-to-one functions. So it doesn't matter what type of log we're working with, whether this was a common log or a log with a base of whatever. Natural logs work the exact same way. So we see the same properties with natural logarithms. We can use those properties to help solve equations. So I'm going to work this out. I have log base 5 of 5 to the 7th power. This follows that same third property there, so it's automatically going to equal a 7. Log base 6 of 1, because we're taking a log of 1, it's automatically equal to a 0 based off the first property. Log base 3 of 3, we're taking the log base 3 of the same thing, so that means that it's going to equal a 1. Number 4, we see 5 to the log base 5, so those two things are the same, which means it's just going to equal the 125 that's inside the log. 5 is a little bit trickier, and we would see that because the natural log of 1 over e, another way to write that is saying e to the negative 1 power. That's just using our negative exponent rules. So if I saw natural log of e to the negative 1, it would automatically be the exponent of negative 1 because a natural log is log base e, and we see something similar to what we just saw with 3, where the base and the inside of the log were the same. So we're left with whatever the power is. That's that property 3 that we're working with. So I would say this is equal to negative 1. Similarly, e to the ln, so e to the natural log of 5 is just going to equal 5 because that's still an inverse property. Now, natural log of 1 divided by 3. That looks a little bit different, but let's look at what is the natural log of 1. the natural log of 1 is always going to equal 0 because e to the 0 equals 1. So what we're saying is we have 0 on top divided by 3. And 0 divided by 3 is still just 0. Last thing, 8 says 2 ln of e, so 2 natural log of e. The natural log of e is just 1 because e to the first is equal to e. And that follows the second property there, where you're taking the log where the base and the inside are the same. So we end up saying 2 times 1, which is just 2. Now we get to the actual properties of expanding and condensing. So these properties are super important for you to memorize, but we have the product property, quotient property, and power property. These are the 3 main ones. We did talk about the change of base property in the previous video because we might need that if our calculator doesn't have a base button. But either way, the other 3 are going to be used to help expand or condense our logarithms. So if you see a product inside of a log, like x times y, we can expand that into 2 different logs with addition. So it's a log base b of x plus log base b of y. Notice the bases are all going to stay the same, but that multiplication expanded into adding 2 logs together. With a quotient or division, we have x over y, and we turn that into subtraction. So log base b of x comes first, it's in the numerator, minus log base b of y, what was in the denominator is being subtracted. The last one's our power property. So if I have a power of p in this case, what happens is I can bring it down in front of the log, and it's saying p times log base b of x. You have that many of those. And those 3 we're going to use to help expand. So let's look at expanding first. If I have log base 2 of 3x, this is using our product property. So we can identify the property we're going to use to say log base 2, the base stays the same, and then inside the log is a product. So I can expand that product with addition. And it would say log base 2 of 3, close the log, plus log base 2 of x. We've just expanded that product property. Similarly, we could condense with the product property if we see 2 logs added together. So we're just going to go backwards from what we saw here. Where 2 logs were being added together, we could condense them down into 1 log with multiplication. I'm going to condense and say this is log base 3 of, and what we're doing, we're multiplying the insides of the log. So this is going to be really 4 times x plus 2. And if I distribute, we could simplify it a little bit further to say log base 3 of 4x plus 8. But I can't do anything else inside of that log. Now the second one down here, second row, has log base 4 of, and we see a quotient property. Quotient property. So with that division, we're going to separate into 2 different logs and have log base 4 of x on top minus log base 4 of 4. So the numerator came first, we subtracted our denominator of 4. This could actually simplify a little bit further just because we see in the second one log base 4 of 4. That's a property we just talked about. So that's really -1. And the second one on the second row, we still have subtraction. We're trying to condense. So this is working backwards with the quotient property. And if I condense this, this would say natural log of, we're subtracting, so that tells us what is in the numerator and denominator. 15 is on top, 3 is on bottom. And I could actually simplify that further. So natural log of 5, because 15 divided by 3 is 5. All right. Our third row, we see the power property. What we're doing with that 2 is the exponent, and it's going to come out in front of the log to say 2 times log base 3 of x. If we want to work backwards, we see a number in front of the log, we could bring it back up inside and say log base 2 of x to the 1/3. We see a 1/3 power, so if we have talked about rational functions or rational exponents before, we would say log base 2 of the cubed root of x. We can use that rational exponent property to create that cube root. Now I just want to try to combine some of these. So I've got log square root of x, and it doesn't look like there's a property in this at all because there's no multiplication going on, there's no division going on, and we don't see an exponent, but because of that rational exponent property, there actually is. So I'm going to convert this to log of x to the 1/2, since it's a square root. Now we have a power property. We're going to take that power and bring it to the front of the log. So it says 1/2 times the log of x. This one is a common log. It's base 10 because it didn't have a base written. With the next one, I can see that there's an exponent that should be brought up with that power property because there's a number in front. So I could change this to the natural log of a cubed plus the natural log of b squared. But because there is another property, we can condense even further. We see where we're adding 2 logs together. So I'm going to add those logs by using the power or product property. So you're not really adding the logs together, you're condensing down into one log with a product. So this is a cubed times b squared. And that was just using this product property up here. Last one, or last row, we've got a 2 that we can bring out front. Actually, this is the same one as what we had, so let's ignore that. Sorry about that. All right. So this becomes a little bit more of a challenge for you. If you want to pause the video, you can challenge yourself and work through these out and practice on your own, but these are a little bit more of expanding and condensing with just quite a few properties together. If you want to try a few out with me before you pause the video, go ahead. But this one, we have the natural log of all of this stuff. And it didn't have parentheses around it, but you could put them there. All of that is inside of the log. What I'm noticing is that they're all being multiplied together. So I could take that and turn it into the product property. That product property would say natural log of 5 plus the natural log of x squared plus the natural log of y plus the natural log of z to the 4th. So using that product property, we've expanded into 4 different logs. But we're not all the way done because there's still a property that we can use. We can use the power property. So I'm just going to take those exponents and bring them out front of the log that they're associated with. So that 2 would go in front of that second log, and the 4 goes in front of the last one. So natural log of 5 plus 2 natural log of x plus the natural log of y plus 4 natural log of z. And number 2, we see a product because those things are being multiplied together. So I can apply that product property to say log base 3 of x squared plus a log base 3 of the square root of y, but I'm going to go ahead and make that a y to the 1/2. Just changing that square root to a rational exponent. Because when it's an exponent, then I can use that power property. So let's bring that out front to say 2 log base 3 of x plus 1/2 log base 3 of y. 3, we see a quotient. So I'm going to go ahead and use my quotient property to subtract these. And I'm going to say log of 10a minus log of b to the 7th, c to the 3rd. And then I can combine. So I'm going to expand one more time. That would say 10 plus log of a. And this was subtracting this whole thing. So really I'm subtracting a log of b to the 7th plus a log of c to the 3rd. But what we're going to see is that we're subtracting each piece. So really what I tried to do is when there's more than one thing in the bottom, it's just going to both be subtracted when you're combining. So it would say log of 10 plus log of a minus log of b to the 7th minus log of c to the 3rd. So I usually don't write out that middle step there because what I see when I'm expanding is that there's multiplication on top. So that's how I get my log of 10 plus my log of a. But I also see the division. So minus the log b of 7 and minus a log c to the 3rd because both of those are in the denominator. Now I'm going to simplify using that power property. So I could bring that down and say 7 in front and a 3 in front. So log of b minus 3 log of c. This first one we can also simplify, mainly because we see that property that we had on the first page. Log of 10 is the log where the base is the same as what we're taking the log of. So it ends up being a 1 plus log of a. That had a few things to actually expand. 4, we have a cubed root. So what that is going to mean is that each of those is to a 1/3 power. So I'm going to change this to the natural log of 4m squared to the 1/3 power. Now you could take both of those things and do 4 to the 1/3 and m to the 2/3, since it's an m squared and you're multiplying those exponents. But either way, we have a product property that we're going to end up expanding. So this would say the natural log of 4 to the 1/3 plus the natural log of m to the 2/3. We use the power property to reduce it down. So I'm going to bring that power property in front. And we've got 1/3 natural log of 4 plus 2/3 natural log of m. 5, we have a 5th root. That means we're going to do to the 1/5 power. So you have log base 4 of x squared plus 5 to the 1/5. The thing about this one that's different is that we have this plus sign on inside. I don't distribute an exponent across addition. That's not a distributive property that exists. That's something that people make up, but it doesn't exist. So there's nothing I can do with this 1/5 besides saying, well, the power property would say I could bring it in front. I'm going to bring that in front to 1/5 log base 4 of x squared plus 5. I can't expand that any further because there's not a property that lets me expand addition inside of a log. If we go back to what those properties were, we could expand multiplication, we could expand division, and we could expand using the power property. We could not expand if this was addition inside of the log. So that doesn't exist. That's a common mistake that you'll see down at the bottom, is somebody trying to take a log like this and expanding here. We can't do that. So just know that these are all common mistakes that don't exist. So don't do these. All right, so this would be our final answer for number 5. If we work backwards and we're condensing, I have some multiplication because of the product property. We see an addition of 2 logs. That means we're going to turn that into multiplication. So log of x y to the 6th. Actually, I combined 2 properties there. We first use that power property, and then we're subtracting log of z minus 3 squared. There's another power property. So I always bring the power property first, and then we can use the product and quotient property. Now I see the quotient property because of that subtraction of 2 logs. So the numerator would say x y to the 6th, and the denominator is z minus 3 cubed, or squared, sorry. It would be okay to leave it this way. You could also expand that out if you wanted to z squared minus 6z plus 9. But it's not required that you do that. I just want you to at least be aware that those are 2 same formats of that problem. All right, now 7, we got this 1 by condensing or expanding it down. So look back where we got a 1 earlier. It was because I took the log of the same thing. So I would have the log of the same thing. These are all natural logs. So I'm going to change this to the natural log of e so that we would get a 1 there, plus the natural log of x squared if I use that power property. I'm going to bring that up. And then minus, I'm not ready to use the quotient property, but I know the minus is going to be our quotient property. Now that we have all the powers gone, I can use the quotient property. So this part is our product property, and this will end up being our quotient property. So I'm going to condense it down to the natural log of what we see multiplication here is going to be on top, so e times x squared. In the denominator is the 8 and the y, so 8y. All right, number 8, I have lots of powers, so this would be a power. of 1/2, a power of 3, a power of 1/3. I'm just going to do that part first. Log base 5 of x to the 1/2 plus log base 5 of y to the 3rd minus log base 5 of z squared plus 9 to the 1/3 power. Now I can do the product property on top, and minus tells me I'm going to be doing a division, so I have a quotient property. Let's condense. I've got log base 5 of, if I do the top, it's x to the 1/2. That's the square root of x. Times y to the 3rd, so y cubed. Minus, there's the denominator, and it's z squared plus 9 to the 1/3. 1/3 I can convert to a cube root, so cube root of z squared plus 9. All right, so number 9, still do your power property first. The last one doesn't have a power, but I've got log base 2 of 3 squared plus log base 2 of a to the 7th minus log base 2 of b to the 1/2 minus log base 2 of c. All right. There's going to be some division since I've got the minuses. On top, we're going to have a product property. 3 squared is 9, so I could work that out as 9 times a to the 7th. In the bottom, we're going to have a b to the 1/2, which is the square root of b, and a c. The c doesn't have a square root because it didn't say c to the 1/2. So you might actually see this written as log base 2 with the c in front of the square root of b. And that would be what's considered a little bit cleaner version of that. All right, the very last one, we see a plus sign, so we're going to be condensing with the product property. We see minus sign, there's the division, the quotient property. The natural log of x squared plus 1 is going to go in the bottom. That's what we are subtracting. On top, we have x minus 4 times an x plus 6. So it would be okay to leave it that way. You also might see it where it's multiplied out. Not really expanded out, but multiplied. So x squared plus 1, can't do anything on that in the bottom, but I could multiply the numerator to be x squared plus 2x minus 24. Both of those would be considered acceptable forms of those that. All right, the last part was that common mistake, so just to kind of clarify, you cannot divide inside of logs like this. So if it's log of 6 divided by log of 2, it's not log of 3. It would have to say the log of 6 divided by 2 for us to be able to condense. It doesn't. We talked about adding inside of logs. And then here, if this was a 2 outside of the log, like the whole log is being squared, now that would be different. And you can't just bring the 2 in front, because a squared, that thing that's being squared, that means that there's 2 of those. The power property only applied to when that thing inside of the log was being squared. So notice how I wrote that. The 2 is squared for the x, but it's not like this thing is being squared, the log itself. So just be careful and be on the lookout for something like that. All right, I would definitely try the ones in the lab manual for these. you need plenty of practice on these logarithms.